So we continue with our minimization problems for this example, and this example is similar to the previous example, and this is producing daffodil bulbs, and it reads, Timber Landscaping operates 2 floral farms. Its smaller Abby's Acreage farm harvests 200 yellow daffodil bulbs, 100 orange daffodil bulbs, and 100 white daffodil bulbs. At Brooklyn's Farmstead, it harvests 100 yellow, 200 orange, and 600 white daffodil bulbs. Timber Landscaping needs to harvest at least 1,000 yellow, 1,400 orange, and 3,000 white daffodil bulbs to fulfill an order. It costs Timber Landscaping $200 per day to operate Abby's Acreage and $300 per day to operate Brooklyn's Farmstead. Determine how many days each farm should be operated for Timber Landscaping to fulfill the order at a minimum cost. What is the minimum cost? So of course, the first thing we'll want to do is we'll want to go ahead and determine the objective function. So we know that we are looking for a minimum cost. So of course, we're going to use the variable C. I'll put it right down here, C for cost. And we want to determine how many days each farm should be operated in order to maintain that minimum cost. So here we have Abby's Acreage up here. And if we go ahead and we label Abby's Acreage as X, and then we get Brooklyn's Farmstead over here. And if we label Brooklyn's Farmstead as Y, then we could see right here it costs $200 per day to operate Abby's Acreage and $300 per day to operate Brooklyn's Farmstead. So if we do 200x, x being Abby's Acreage, plus 300y, and of course y is Brooklyn's Farmstead, then here's our objective function for this problem here. Now, without the aid of a table, we'll go ahead and we'll put in the constraints. And as you could read carefully right up here, Abby's Acreage, and Abby's is the x's, they need 200 yellow, 100 orange, and 100 white daffodil bulbs. So we'll do 200 yellow from Abby's, 100 orange from Abby's, X is Abby's, and 100 white from Abby's. Don't forget, X's is Abby's. So then if we go through here, we can see that we need 100 yellow, 200 orange, and 600 white from Brooklyn's Farmstead. And of course, Brooklyn is Y. So we'll do plus 100 from Brooklyn's, plus 200 orange from Brooklyn's, plus 600 white from Brooklyn's. And then finally, we could see our totals here. Timber Landscaping needs to harvest at least 1,000 yellow, 1,400 orange, and 3,000 white. So we have at least 1,000 yellow, 1,400 orange, and of course 3,000 white. So here's the objective function, and these are the constraints that model this problem here. Now we'll just go ahead and rewrite this objective function this way. We'll make it equal to C. And of course, the reason we write it like this is because now we want to create a simple matrix that represents this. This is by no means a augmented matrix, and certainly it's not a tableau. It's just a simple matrix that we're going to use in order to transpose. So we'll put in 200, 100, and 1,000, 100, 200, and 1,400, 100, 600, and 3,000, and finally 200, 300, and 1. So here's our simple matrix that we're going to transpose. And recall that the first row is going to be the first column of our transpose matrix. And of course, the second row will be the second column, and so on. So we'll go like this. 200, 100, 1000. So we'll go 200, 100, 1000. Then we'll do 100, 200, 1400, 100, 200, and 1400. 100, 600, and 3000. 100, 600, and 3000. And of course, for the last row here, we'll do 200, 300, and 1, and then we'll close off the matrix. So this is the transposed matrix of our primal problem here, our minimization problem here. We're going to use this matrix now to go ahead and make the dual problem for this scenario here. So then we'll do 200x plus 100y plus 100z, and this is going to be less than or equal to 200. Then we have 100x plus 200y plus 600z. That's less than or equal to 300. And finally, we have 1000x plus 1400y plus 3000z, and that's going to be equal to p for profit. And of course, we recognize it for maximization. So now here is our dual problem, which is a maximization problem, which is the dual problem of the primal problem over here, which is a minimization problem. Now from here, we're going to write each one of these inequalities as an equation with a slack variable. So we'll go 200x plus 100y plus 100z, and then we'll introduce a slack variable. And of course, we'll use u, and that's going to be equal to 200. Then 100x plus 200y plus 600z, and we'll introduce another slack variable, but it's got to be different than this equation up here. So we'll use v, that's going to be equal to 300. And then recall that when we introduce our objective function into here, we want all the variables on one side of the equal sign and 0 on the other. So we'll write this as negative 1000x minus 1400y minus 3000z plus p, and that's going to be equal to 0. So now that we have the dual problem written with slack variables, we can now go ahead and build the simplex tableau, which we use to solve. So we'll go x, y, z, our slack variable u, slack variable v, and our objective function, and put in a bracket. We have 200, 100, 100. We have a slack variable in our first equation here. No slack variable here. Put in our vertical line. And then 200. Then we'll do 100, 200, 600. No slack variable u, but we do have a slack variable v. And then 300. Then negative 1000, negative 1400, negative 3000, 0, 0, 1, and 0. Then we'll close off the matrix, put in our horizontal line. And of course, this is our simplex tableau that we're going to go ahead and use the simplex method to solve. So then, of course, the next thing we need to do is determine our pivot column, and it's going to be the column with the most negative value in the last row here. And of course, that's 3,000 or negative 3,000. And then use these values here, divide them into our constants here. The one that has the smallest ratio would be our pivot row. So we have 200 divided by 100, that's 2. And then 300 divided by 600, that's 1/2. So 600 is going to be our pivot value. So then we could start with 1/600th of row 2. Put in a bracket. 100 times 1 over 600, that's 1/6. 200 over 600, that's 1/3. 600 times 1 over 600, that's 1, 0, 0. 1 times 1 over 600, that's 1 over 600. 0, 0. Put in our vertical bar. 300 times 1 over 600, of course, that's 1/2. Close off our bracket. And we bring over the rest. Put in our horizontal line. So then, of course, we can then target this value here. So we could take row 1 minus 100 of row 2. We'll continue down here. 1/6 times 100, that's 50/3. And 200 minus 50/3 is 550/3. 1/3 times 100 is 100/3. And 100 minus 100/3 is 200/3. 1 times 100 is 100. 100 minus 100 is 0. Again, that's the whole idea. 0, 0, bring over the 1. 1 over 600 times 100, that's 1/6. 0 minus 1/6, that's negative 1/6. 0, 0, bring over the 0, and bring down our vertical bar. 1/2 times 100 is 50, and 200 minus 50, that's 150. Close off the matrix, and bring over the rest. Put in our horizontal bar. And now we can target this value here. So we'll take row 3 plus 3,000 of row 2. Put in our bracket. 1/6 times 3,000, that's 500. And negative 1,000 plus 500, negative 500. 1/3 times 3,000, that's 1,000. Negative 1,400 plus 1,000, that's negative 400. 1 times 3,000 is 3,000. Negative 3,000 plus 3,000, that's 0. 0, 0, and 0. 1 over 600 times 3,000 is 5, and 0 plus 5 is 5. 0, 0, and we can bring down our 1. Put in the vertical bar. 1/2 times 3,000, that's 1,500. And 0 plus 1,500 is 1,500. And close off our bracket. Now we fill in the rest. Put it in our horizontal line. Now we've changed this into our unit column. Step 3 says check for negative values. And of course, we do have 2 more here. So the most negative value would be this one here. So this is our first iteration. But we'll go ahead and we'll continue this process again. So our most negative value is negative 500 here in our first column here. So this becomes our pivot column. Then we'll take 150 divided by 550 thirds, and that's approximately 0.82. Then we have 1/2, and we'll divide that by 1/6, and that's 3. So 550 thirds is going to be our next pivot value. So then we could take 3 over 550 times row 1, put in our bracket, 550 over 3 times 3 over 550, there's 1. 200 thirds times 3 over 550, that's 4/11. 0 and 0. 1 times 3 over 550, that's 3 over 550. Negative 1/6 times 3 over 550, that's negative 1 over 1100. And then 0 and 0. Put in our vertical line. 150 times 3 over 550, that's 9/11. Close off our bracket, and we carry over the rest. Put in the horizontal line. And now we could target this value here. So we'll say row 2 minus 1/6 of row 1. We'll continue down here. 1 times 1/6 is 1/6. 1/6 minus 1/6, that's 0. 4/11 times 1/6, that's 2/33. And 1/3 minus 2/33 is 3/11. 0 and 0, we bring over the 1. 3 over 550 times 1/6, that's negative 1 over 1100. Negative 1 over 1100 times 1/6, that's negative 1 over 6600. And 1 over 600 minus negative 1 over 6600, or in other words, 1 over 600 plus 1 over 6600 is 1 over 550. Then we have 0, 0, and 0. Bring down that vertical line. 9/11 times 1/6, that's 3/22. Then 1/2 minus 3/22 is 4/11. Close off our matrix, and finally get to carry over the rest. Put in our horizontal bar, and now we can target this value here. So we'll take row 3 plus 500 of row 1. Put in the bracket. 1 times 500 is 500. Negative 500 plus 500, of course, is 0. That's the whole idea. 4/11 times 500, that's 2011. Negative 400 plus 2011 is negative 2411. 0, 0, and of course bring down the 0. 3 over 550 times 500, is 30 elevenths, and of course 0 plus 30 elevenths, that's 30 elevenths. Negative 1 over 1100 times 500, that's negative 5 elevenths, and 5 minus 5 elevenths is 50 elevenths. 0, 0, and we'll bring down our 1. Put it in the vertical bar. The 9 elevenths times 500, that's 4,500 elevenths, and 1,500 plus 4,500 elevenths is 21,000 elevenths. We'll squeeze it in there. Close off the bracket, and of course fill in the rest. Squeeze in our horizontal bar here. And of course, we've turned this into our unit column. Again, the step 3 then says look for negative values. We still have another one right here. So this is our second iteration. So we'll have to do this, continue with this again. So this is our only negative value here. So this is going to be our pivot column. So then we take 9 elevenths divided by 4 elevenths, and that's 2.25. And then we take 4 elevenths divided by 3 elevenths, and that's 1.33. So this becomes our pivot value. So then we could take 11 thirds of row 2. Put in that bracket. 0, 3 elevenths and 11 thirds, that's 1. 1 and 11 thirds, there's 11 thirds. Negative 1 over 1100 times 11 thirds, that's negative 1 over 300. 1 over 550 times 11 thirds, that's 1 over 150. We have 0. Put it in our vertical bar. 4 elevenths times 11 thirds, that's 4 thirds. I'm going to close off our bracket, and we'll bring over the rest. And again, carefully put in our horizontal bar. And now we can target this element up here. So we'll take row 1 minus 4 elevenths of row 2. We'll continue over here with our bracket. 0, 0 will carry over our 1. 1 times 4 elevenths, 4 elevenths. 4 elevenths minus 4 elevenths, 0. Again, that's the whole idea. 11 thirds times 4 elevenths is 4 thirds, and 0 minus 4 thirds, that's negative 4 thirds. Negative 1 over 300 times 4 elevenths, that's negative 1 over 825. 3 over 550 minus negative 1 over 825 is the same as 3 over 550 plus 1 over 825, and that's 1 over 150. 1 over 150 times 4 elevenths, that's 2 over 825, and negative 1 over 1100 minus 2 over 825, that's negative 1 over 300. 0, 0, and 0. Bring down the vertical bar. 4 thirds times 4 elevenths is 16 30-thirds, and 9 elevenths minus 16 30-thirds is 1/3. Close off the bracket, and we'll bring over the rest. So now we can finally target this last value down here. So we'll say row 3 plus 2400 elevenths of row 2. Put in our bracket, 0, 0, and 0. 1 times 2400 elevenths, that's 2400 over 11, negative 2400 elevenths plus 2400 elevenths, and of course that's 0. 11 thirds times 2400 elevenths, that's 800, and 0 plus 800, that's 800. Negative 1 over 300 times 2400 elevenths, that's negative 8 elevenths. And 30 elevenths minus 8 elevenths is 2. 1 over 150 times 2400 elevenths, that's 16 elevenths. And 50 elevenths plus 16 elevenths is 6. 0, 0, bring down the 1. Bring down our vertical line. And 4 thirds times 2400 elevenths is 3200 elevenths, and 21,000 thirds plus 3200 elevenths is 2200. Could finally close off our bracket and of course fill in the rest. Now as we put in our horizontal bar here, hopefully you realize that you don't necessarily have to fill in the rest once we see that there are no more negative values down here. But it's always good to see what those values are. But nonetheless, we have no more negative values here, so we're done with all of our iterations. And we could see right here that P would be equal to 2200. Now, since we're talking about dollar amounts, we'll go ahead and we'll put in a dollar sign there. And of course, the solution for our dual problem is going to be the same for the minimization problem, so C is also going to be equal to 2200. Of course, it says what is the minimum cost? That's our $2,200. But again, it says how many days each farm should be operated. Don't forget Abby's acreage was X, Brooklyn's farmstead was Y. And of course, we're going to find those values under the columns, in the last row under the columns of our slack variables. So just going from left to right, here is Abby's right here, that's X, and here is Brooklyn's right there, that's Y. So right here, we have 2 days. Abby's acreage should operate for 2 days, and Brooklyn's should operate for 6 days. So X should be equal to 2, and Y should be equal to 6. And if you recall, our objective function is C is equal to 200x, and x again is 2, plus 300y, and of course y again is 6. 200 times 2 is 400, and 300 times 6 is 1800, and 400 plus 1800 is $2,200. So it's a lot of work. It seems very tedious, but it is very simple and straightforward, but very tedious, but nonetheless an ingenious way of being able to solve these minimization problems. And there you go.